Hi, it's Paul Anderson, and in this video I want to talk about CER. It's a framework for making explanations in the science classroom. It's a skill that teachers should give their students, and students should have if they want to improve their scores on lab write-ups, on essays, or on big exams. But before we talk about CER, let's talk about science in general. In science, what we're doing is gathering evidence through investigations of the natural world. We're then coming up with explanations that are critiqued over time. But unfortunately, a lot of the time in a science classroom, the investigations are developed by the teacher itself, and the students are just going through a cookbook lab, and so we want to avoid that if we can. But also, we spend too much time on the investigation itself, on the variables and controlling the variables. And then when we get to the end of coming up with an explanation of what we learned, we kind of fall down on that point. And so the CER is a framework that makes this explanation making explicit. It was developed by Dr. Kate McNeil and Dr. Joe Krychek. I'll put links to some of their material down below, but it's an acronym. The C stands for claim, the E stands for evidence, and the R stands for reasoning. Sometimes you'll hear rebuttal added at the end of that. That's looking at somebody else's claim, evidence, and reasoning. But this is my model for how claim, evidence, reasoning works. Claim is an answer to a question that's asked. Evidence is going to be what you gather, empirical evidence that's gathered in the lab or through research. And then reasoning is going to be a logical connection between the evidence and the claim that you're trying to make. Now, students will generally do really good at the evidence gathering, but they fall down when it comes to this logical connection. And so a good tip is to make sure that your reasoning is based in some kind of a scientific definition, rule, principle. That's a way that in science we can all agree on that. Now, what should a teacher provide? A teacher should simply provide a good question and a way to answer that question. So let's say in the science classroom I give my students a bunch of dice, but they're different looking dice. They're skew dice that look like this. And I ask them the following question. Are these skew dice fair? Now, they could start gathering evidence right away. They could roll the dice a bunch of times. We could measure the dice, look at their center of gravity, maybe measure all of the sides to make sure that they're all the same. But before we jump in and start doing evidence, make sure that you've actually framed the question and you understand what's being asked. Make sure that you could define everything that's in this question itself. I'm sure you know what skew dice is, but are we all in agreement with what it is to be fair? Well, let's define it. Fair is this idea that each side has an equal probability of ending up on top. Now, once we have that definition, you can use that in that logical connection. Let's get to an actual science question that we could answer. Is air matter? That's a question you could answer in the science laboratory. Before we dig in and start gathering evidence, however, we should frame the question and make sure that we understand what every term in there means. So what is air? Air is an invisible substance that surrounds the earth. What is matter? Matter is anything that has mass and takes up space. What else do we know about matter? It can be neither created nor destroyed. So sometimes it's helpful at the beginning to get all of these listed out so that we can use them at a later date. Now we can use a form like this to do our claim, evidence, reasoning. Claim is going to be an answer to the question, but generally we don't start there. We have to start by gathering evidence. So perhaps I take a balloon, put it on a scale, and then I fill up a balloon and put it on the same scale. I'm trying to show that there's an increase in mass. And then maybe I want to look at the takes up space side of the matter. Maybe I take a bottle filled with water, pump air into it, and I can displace some of that water. And so now I can make a claim. Yes, air is matter. That's going to be my claim. I've gathered evidence, but now how do I do the reasoning? Well, the reasoning is easier if it's tied to one of those scientific definitions that I had before. So let me read you my reasoning. The mass of the balloon increased when air was added, indicating that the air had mass. The air displaced a volume of water, indicating that the air also has a volume. Since matter must have both mass and volume, my evidence suggests that air is matter. That reasoning part is what we hope our students will start to write, and they never do. Generally, when they're doing a lab write-up, they simply tell us the evidence they gathered over and over and over in more detail. But what we really want is a connection between the evidence that you gathered and the explanation that you're trying to make. Now, we could do a rebuttal on that. We could say, well, let's look at the evidence here. You blew this up, so that's air coming from your lungs, so it's not coming from the environment, so that could impact it. Maybe it's water there. And also, it looks like there's air right here. And so are you really measuring air, or are we measuring air pressure? And so now we can have argumentation, or we can talk about the evidence or the reasoning. Now, all you do when you're doing labs that use claim evidence reasoning is just give them a good question and a material to answer the question. I could give them a bunch of magnets and I could say which of these is the strongest. Give them a bunch of paper clips, rulers, whatever, rubber bands, washers, and they have to answer this question. The first question they should ask you as a teacher, however, is let's make sure we frame the question and define everything inside it. What is magnetic strength? And if we say it's a measure of the attractiveness or attractive force between a magnet and magnetic material, do we know what a force is? Once we have all of these definitions out there, it's easier for you to do a claim evidence reasoning. Now, these are pretty low-level science questions. We could do it in a chemistry lab as well. One thing that puzzles students a lot of the time is when you boil water, it gets to around 100 degrees Celsius and then it stays there. I used to have kids who would look at their thermometer and thought it was somehow broken. But we have this curve that looks like this. So as we heat something up, as we apply heat to it, as it goes from a solid to a liquid to a gas, we get these plateaus where the temperature stays the same. So I could ask them a question. What happens to the energy during a phase change? What happens to the energy right here? And so what they should be doing is coming up with an explanation. They should be coming up with a claim. How should they do that? Number one, frame what the question is asking. Do we know what energy is? Do we know what a phase change is? Do we know any things that might be applicable to energy, like the law of conservation of energy? Now they're going to gather a bunch of evidence. What's some relevant evidence? We can see a phase change from liquid to gas is occurring right here. We can see during this time that we're adding heat, but the temperature is not going up. And so you could gather a bunch of evidence, but then making that connection, making the reasoning, it's going to be based in some kind of a principle. And you could try to make that connection down below. You could write your reasoning in the comments if you wanted to. So what is claim evidence and reasoning? It's a way to make explanations. And if you step through those three parts, when you're ever asked to explain what you learned, as long as you say, here's my claim, here's the evidence, and here's the reasoning to back it up, you're going to do much better than you have in the past. I wanted to thank Kirsten Marinsky. He put this forward as an idea of a video. If you have a suggestion for a video you'd like me to make, put it again in the comments down below. But that's claim evidence reasoning, and I hope that was helpful.